Welcome to section 1.7. This is the 9th session of the CISSP exam prep series. In this session, we'll learn how to find and rank threats before they hurt you. We'll answer several questions. What is threat modeling? When do you do it? Proactively or reactively? How do you identify threats? How does the STRIDE model categorize them? How do you diagram and decompose a system? And how do you prioritize what you find? Why does this matter beyond the exam? Because building blind almost guarantees expensive surprises. Picture a team shipping a new mobile wallet with no thought to how it might be attacked. Months later, they are patching frantically while users lose trust. Model the threats up front, and you design defenses in from the start, far cheaper than bolting them on later. On the job, this is how you turn security from firefighting into engineering. What is threat modeling? It is the process of identifying, categorizing, and analyzing potential threats. For each one, you work out the possible harm, the odds it happens, how much you should worry, and how to remove or reduce it. It is not a one-time event. You start it early in design and keep it running across the whole life cycle. Mature software teams fold it into their development life cycle to catch flaws sooner and cheaper. Think of a building inspector who checks the plans, the construction, and the finished structure, not just one snapshot. When do you model threats? Proactively or reactively? Both, and the distinction matters. The proactive, defensive approach happens early, during design and specification, predicting threats and baking in defenses as you build. Integrated security is usually cheaper and more effective than security shoehorned in later. The reactive, adversarial approach happens after a product exists, hunting for problems you could not foresee. This is where threat hunting lives, searching for evidence of compromise once warning signs appear. It powers ethical hacking, penetration testing, source code review, and fuzz testing, which floods software with strange inputs to find hidden flaws. Think of designing a car with crumple zones versus crash testing one already built. You want both. How do you identify threats in the first place? You use a structured approach because the possibilities are nearly endless. 3 common lenses help. Focused on assets, you start from what is valuable and ask what threatens it. Focused on attackers, you profile likely adversaries and reason from their motives and tactics. Focused on software, if you build software, you consider the threats against it directly. Pairing threats with vulnerabilities reveals the ones that truly put assets at risk, which is the whole point, to prioritize. Think of protecting a home by studying your valuables, your likely burglars, and your weak doors and windows, all 3. How does the STRIDE model categorize threats? STRIDE is a scheme that sorts threats into 6 named types, so you do not miss a category. Spoofing is faking an identity to slip past controls. Tampering is unauthorized changes to data in transit or at rest. Repudiation is denying an action you actually took, sometimes framing an innocent party. Information disclosure is leaking private or controlled data. Denial of service is blocking legitimate use of a resource. And elevation of privilege is turning a limited account into a powerful one. Modern modeling adds concerns for AI systems too, like biased algorithms that produce unfair outcomes. Think of a checklist of the 6 ways a con artist might work a room, so none surprises you. Are there fuller methodologies beyond STRIDE? Yes, several structured ones exist. One is a 7-stage, risk-centric method that walks from defining objectives through scoping and decomposing the application into threat and vulnerability analysis, attack simulation, and finally risk management, choosing countermeasures based on what your assets are worth. Another is a visual, agile approach that folds threat and risk management into agile development at scale. These are just 2 of many available from community groups, vendors, and government bodies. Think of choosing a recognized project methodology. You pick the one that fits how your team already works. How do you diagram the potential attacks? You draw the system to see where the danger lives. Map each major component, the boundaries between security zones, and how data flows and moves between them. Then identify every technology involved and, for each element on the diagram, the attacks that could target it. Consider all forms: technical, physical, and social, not just the obvious code level ones. Complex systems may need several diagrams at different levels of detail. Think of sketching a floor plan and marking every door, window, and hallway a burglar might use. How do you decompose a system in reduction analysis? Reduction analysis means breaking the system into smaller parts to understand its logic and interactions. You split an application, system, or environment into modules, protocols, or even departments. Then study each part's inputs, processing, storage, and outputs. As you decompose, you pin down 5 key things: trust boundaries, where the level of trust changes; data flow paths, how data travels; input points, where external data arrives; privileged operations, actions needing elevated rights; and the stated security stance, your assumptions and policy. The better you understand the pieces, the easier the threats are to spot, and each one should be documented by its means, target, and consequences. Think of taking apart an engine to see exactly where it could fail. How do you prioritize the threats you find? You rank them so the worst get attention first. One simple method multiplies probability by damage potential, scoring each threat toward a top severity number. An even simpler method rates probability and damage as high, medium, or low, plotting them on a risk matrix or heat map, where high sits in the danger corner and low barely registers. A richer method rates each threat on 5 questions: damage, reproducibility, exploitability, affected users, and discoverability, to gauge its real seriousness. Once ranked, you choose responses weighted by cost and effectiveness, adjusting architecture, operations, and defenses. Think of triage in an emergency room, treating the most dangerous cases before the minor ones. So let's bring it together. Threat modeling identifies, categorizes, and analyzes threats across a system's whole life. You do it proactively in design and reactively through threat hunting after deployment. You identify threats by focusing on assets, attackers, or software, and you categorize them with stride and fuller methodologies. You diagram the system, decompose it to expose trust boundaries and data flows, and then prioritize with methods like probability times damage, a risk matrix, or the 5-question rating. Model early and rank ruthlessly, and you spend your effort exactly where the danger is greatest. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.